Welcome to my video lecture based on Numericals on Superposition theorem. Paper name Electric Circuit Theory. Paper code PCE 301. This total syllabus is based on markout curriculum, and in my previous lecture I have discussed various about some signals, and later on I have discussed the network theories, Ohm's law, Kirchhoff's voltage law, current law, loop analysis, mesh analysis, related problems. Those things I have already discussed in my previous lecture. So in this lecture I will mainly bring some numerical based on superposition theorem. In my last lecture I have shown you what is superposition theorem, what are the basic conditions for doing superposition theorem, and proof of superposition theorem, what are the limitations and what steps need to be followed in superposition theorem. Those things I have already discussed in my last lecture. In this lecture I will show that how numerically we can solve the superposition theorem related problems. Basically in network analysis technique, superposition theorem is very much important theorem, and this theorem is based on a concept that the network must be linear and bilateral and more than one source should be present there. So let us consider, this is an example. Here we have taken, using superposition theorem, calculate the current through 2 plus J3 ohm impedance branch of the circuit shown in the figure below. Here we have two sources, both are voltage sources. One is 30 volt source and another one is 20 volt source. And we know that the internal resistance of voltage source is near about 0. So when we will consider one source, that means as per superposition theorem, one source will be acting on and remaining all other sources will be deactivated by its internal resistance. So when 30 volt source will be acting, I will deactivate 20 volt source, and when 20 volt source will be acting, I will deactivate this 30 volt source. Okay, and then we have to find the current through 2 plus J3 ohm branch. That means we have to find the current through this branch 2 plus J3. So for when 30 volt source is acting, I will calculate the current through this 2 plus J3 branch. Let this is I1 for 30 volt source, and when I will calculate the 20 volt source, then 30 volt will be deactivating, and again we will calculate the current for this 20 volt source. Let this current will be I2, and in the latter stage our actual result will be summation of these two currents, that means I1 plus I2. So let's see how we can solve this problem. So for first case we are taking that 30 volt source is acting alone and 20 volt source has been deactivated, and as the internal resistance tends to 0, so path I have shorted. Okay. Now I will calculate the total impedance Z. Okay, how we will calculate? First we will see which resistances are connected in series, which one in parallel. So let's see. First, total current is coming through 5 ohm branch, then it is divided in this J5 ohm plus 2 plus J3 ohm branch. Then again this J3 ohm branch, 2 plus J3 ohm branch current divided into these two parts, 4 ohm and 6 ohm. That means wherever the currents are dividing, those branches are parallel. So definitely 4 plus 6, these two branches is parallel in connection. So it will be 4 parallel 6. First we will calculate. Then this 4 parallel 6 will be combined here. So that means the circuit will be like this. This is 30 volt source. Then this is 5 ohm. Then this is J5. Then this is 2 ohm plus J3 ohm. Then another resistance which is combination of 6 parallel 4. So ultimately this becomes, this is 2, this is J3, this is J5, this one 5, this one 30 volt. Okay. So by calculating these two, we are getting less 6 into 4, that means 24 divided by 10, that means 2.4. Now we will add this 2.4 plus 2, that means 4.4, which is written here. 4.4 plus this J3. These three are in series. So the total resistance of these three branches 4.4 plus J3, and again this one is in parallel, so 4.4 J3 into J5 divided by 4.4 J3 plus J5. That means ultimately our parallel branch becomes J5 parallel with 2 plus J3 plus 2.4. So these two will be parallel. This calculation, it has been done here, and with all this value 5 ohm is in series with all these parallel branches, so it will be sum up with 5. Okay, so here total impedance we have calculated. Now we will calculate the total current which is passing through this 30 volt. So this I dash, definitely it will be V by I, V by Z from Ohm's law. So 330 volt is our value of voltage, and Z we have calculated. Regarding this one, we are getting the total amount of current, that is 4.06 minus J 1.17 ampere. Now using current divider rule, we will calculate the branch current of I1 dash. Definitely current divider rule tells that total current multiply with opposite parallel resistance. So here total current is I dash. Okay, so I dash into, we have to calculate the current through this branch, that means opposite parallel is J5, so we will multiply this with J5 divided by the total resistance present. Here total resistance is 2 plus 2.4 plus J3, that means 4.4 J3 plus J5. These all are total resistance, that means 4.4 plus J8 is our total resistance. So from here we have calculated the value of small I dash by when only one source is acting alone. That means when 30 volt source is acting alone, we have calculated the current through 2 plus J3 ohm branch. In a similar way, now I will deactivate the 30 volt source and 20 volt source will be acting, and again in similar way we will calculate the current through 2 plus J3 ohm, and then the total result we will get. So similar way, now 20 volt source is acting alone, this one, and 30 volt source has been deactivated. In similar way, we will calculate the total impedance, that is Z here, and that will be again as per previous calculations we have made. That is, we have to define which one is series resistance and which one is parallel. So here 4 ohm current, here current I double dash is flowing, then after coming here it is divided into two branches, and after this point it is again divided into two branches. That means 5 ohm and J5 ohm both are in parallel. Then after calculating this one, this will be again in series with this 2 ohm plus J3 ohm. Then again this 6 ohm plus all this will be parallel with this 6 ohm. Then this total is in series with 4 ohm. So the total calculation same way, 4 plus this 4.5 plus J 5.5, this has been counted from this calculation. After calculating this 5 plus J 5 ohm, then put it in series with addition, this has been written directly, and this 6 ohm in parallel. So the total resistance impedance value we have got, that is 7.31 J 1.41 ohm. Now in similar way we will calculate the total current by dividing the total impedance with voltage. We are getting that I double dash is 2.64 minus 0.059. Now again we apply current divider rule here, and we will get the current through this 2 plus J3 ohm branch. Here the direction of the current is opposite from previous one, so it will be taken as minus, that is minus 1.064 minus J 0.848. Now we are, as per superposition theorem, we have to sum up these both currents to getting the actual result, and we are getting this one, that is our result is 1.733 angle 40.14 ampere. This is the result of superposition theorem solution. Now again we are taking another example. Here we have to find the value of V0 using superposition theorem, and here the factor is taken that our voltage is 30 sin 5t and current is 20 cos 10t. So here for calculation easier purpose, we will calculate the value of XC and XL. So when the voltage source is acting alone, the value of XC will be J divided by 5 plus 0.2. Why 0.2 is because the capacitance value is 0.2 given, and we know that Xc means 1 by omega c, and here omega is this 5. So we have put it 5 into 0.2, that is the value of Xc is minus J1 ohm. And again we have to calculate the value of XL. We know that XL means omega L. So again we have put the value of omega, and the value of L is given, that is 1. So XL value is J5. That means here this value is minus J1 ohm and this one is J5 ohm. Now we will start. We will deactivate first current source, and when we are deactivating current source, the path becomes open circuit. So this is open circuit basically, and now we will calculate the current through this branch. So only 30 volt source is acting here. It is passing through 8 ohm. Then it divided in these two branches. Okay, so for easier solution, we have taken Kirchhoff's current flow in this branch. So it will be 30 minus V0 divided by 8 ohm, this one, this branch current. Again V0 divided by minus J1, that is the current through this branch. Then again the current through this branch will be V0 divided by J5. Summation of currents looking at a node equals to 0. So in applying that KCL, we are calculating that the value of V0 is this one. Okay. Now when the current source is acting alone, definitely the voltage source will be deactivated and the path will be shorted here. And now we will put the value of Xc. So here Xc will be omega 1 by omega c, that is definitely minus j into 1 divided by, here omega is 10 because this current source is acting. This is the omega for current source, that is 10. So here we have taken omega as 10 and the value of X becomes minus j 0.5, and again we will calculate the XL value for the current source. So again omega value is 10 and omega L, that is L value is 1, so it is J10 ohm. Okay. Now by applying KCL we will again calculate the current through this minus J05 branch, this branch current we will, this branch voltage we will calculate by applying KCL. So similarly we will calculate that, and we are getting the value of voltage is 1.051 angle minus 86.24 degree. So by applying superposition theorem, we have to sum up the all voltage sources. Whatever amount of voltage we are getting from previous steps, now we have to sum those up, and after summing up, we are getting, this is the result. This one is our result. Okay. So let us consider another problem where one voltage source and one current source is there. So here we have taken first voltage source and deactivating the current source. So the path becomes open circuit, this one, and 5 ohm voltage source is acting here. And in next step we will deactivate the voltage source, current source will be acting. So voltage source deactivating and path will be shorted. So we have shorted the path. So the value of current we can calculate from our figure 1, that is 5 divided by 4 minus J2 ohm. Okay, that will be our total current flowing through this branch, that is here we have taken that I0 dash. Okay. In our next step we will calculate the current through I0 double dash when 2 ampere current source is acting. Here we will apply current divider rule. Total current divided by opposite, multiply with opposite parallel resistance, that is 4, divided by the total resistance present, that means 4 minus J2 ohm, and we are getting the current as this one. Now as per superposition theorem we have to sum up this total current we are getting from both sources, and after summing up we are getting the result, that is 2.9 angle 26.56 ampere, and this is the result of our superposition theorem. So all 3 examples I have shown you related to superposition theorem, and based on those you just practice different problems related to this. Remember, you have to first think about one source will be acting alone, and remaining all other sources you have to deactivate, and for individual sources you have to calculate the current or voltage through the desired branch, and desired branch will be that branch from through which we need to calculate the current or voltage as per the problem given. Okay, that will be our desired branch. Now, for after calculating all the currents or voltages, individual source acting, then we will combine all the currents and voltage we have calculated already. Then we will sum up these all results and we will get the actual result of superposition theorem. So this is the superposition theorem examples I have shown you. Now I will suggest you to practice different problems related to this, and the circuit theory book of Abhijit Chakraborty is very important regarding the problem solution of superposition theorem and all network problems. So thank you all for listening my lecture.